Okay, 3-1 to 3-2 review. Calculators are allowed, and this is the free response question on the exam, or similar to it, I should say. Number 10, we're given a function that's a polynomial, and our first job is to write an equation of a normal line. So in order to write an equation of a line, I need a point, and I need the slope that goes with that point. So if we look here, my point has an x-coordinate of 0. So I'm going to get the y-coordinate that goes with that point by plugging 0 into the function. That will give me 16. Now I ask for the normal line. So the normal line is the one that is perpendicular to the tangent line. So let's figure out what the tangent line's slope would equal. We get that by taking the derivative of f, which is 6x squared minus 30x plus 24. Then we plug in 0 to get the tangent slope at this point, and we'll have 24. So now the normal slope will be the opposite reciprocal of that. Once we have the point and we have the slope, we can write the equation of the line, which is y equals the slope times x minus the x-coordinate plus the y-coordinate. Now let's look at B. B says finding the x and y coordinates of all points where the line tangent to the graph is parallel to the x-axis. Well, let's remember that word parallel means that the slopes are the same. So if we're parallel to the x-axis, that means the slope of the tangent line needs to equal the slope of the x-axis, which is 0. So what we're really going to be doing is solving for when this f prime, which is 6x squared minus 30x plus 24, we want to know when that equals 0. So the easiest way to see this is to factor. I'll get a 6 that comes out, and then I can factor even further and get an x minus a 4 and an x minus a 1. So I've now found the x coordinates that generate horizontal slopes. Set each of these factors equal to 0. I've got x is 4 and x is 1. So now to get the y coordinates, I just need to plug 4 into the original curve. Notice I'm not plugging it into the slope because I'm not interested in the slope at 4. I want to know what's the point on the graph of f. So I'll take the 4, plug it into the original function, and I get a 0 out. And then I take the 1 and plug it in, and I'll get a 27. So the 2 points on the graph of f where the tangent line is parallel will be 4, 0 and 127. So last part C is asking for us to find the x and y coordinates of all points on the graph of f where the line tangent to the graph passes through the origin. So this is one of my favorite problems because I did not give you the points. I ask you for the points, and it's a tangent line. So what this means is because we don't know the point, we're going to use a general point. We're going to use a variable. So we'll let the x-coordinate be a. I'll plug a into the function. And then I need the slope that goes with that point, which is f prime with an a plugged in. So that will be a 6a squared minus a 30a plus a 24. Now I have something that looks pretty complicated, but I can still write the equation of the line. The line will be y equals this slope. Now notice that the slope has a's in it. A lot of people will make the mistake and not evaluate the slope at the point. They'll neglect to plug in the a, and they'll have x's here. And when they do that, they're not going to have the equation of a line. They'll have like y equals x cubed sorts of things. It'll be a cubic. So you want to make sure that you always, 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 without fail, compute the slope at the point when you're trying to write the equation of a tangent line. So here's my slope at a times x minus a plus the y coordinate that goes with a. So my next step is, now that I have the general line, is I want to plug in the point that I pass through. So the point that I go through is the origin. So that'll mean that my y and my x are both going to be 0, 0, and it will create a true statement. So I'll get 0 equals this 6a squared minus 30a plus 24 times a 0 minus a, which is just a negative a, plus a 2a cubed minus a 15a squared plus a 24a plus a 16. Now, here's what you need to know about the calculator sections of free response problems on the AP exam. If you have a calculator available, once you get an equation, one of the allowed features on the calculator is to solve that equation. So I'm going to put into my calculator that big long equation, and I'm going to solve it. So remember, your syntax on the calculator, you go to your F2 button, which is your algebra, and you're going to select the solve. And in the solve, you need to give it the equation that you're going to solve, which will be this whole big long thing, and I'm actually going to multiply it through. We'll get a negative 6a squared minus, a cubed, minus a 30 plus a 30a squared minus a 24a plus a 2a cubed minus a 15a squared plus a 24a plus a 16 has to be an equation. Right now all we have is an expression, so that needs to equal 0. So I put in that whole equation. Let me double check my signs here. And then we need to also give it a comma and tell it what we are solving for. So I'm going to move this so that I can actually see it while I'm entering it into my calculator. Let's see, I want to make sure. It's kind of a glare. Let me get down here. Alright, we'll try this. So I'll do an F2 solve negative 6, and I'm going to use x's instead of a's, cubed plus 30x squared minus 24x plus 2x cubed minus 15x squared plus 24x plus 16 equals 0 with respect to x. Hit enter, and I can see that the only solution I get is a equals 4. So back on here, I will write that a equals 4, and it said we want the x and y coordinates, so that a is the x coordinate only, which means I've got to plug that 4 back into the original function way up at the top. And notice here in part B I already plugged 4 in, so I already know the y coordinate is going to be 0. So there is my final answer.